Hello, and welcome to a home automator South Africa tutorial. Today we'll be covering the basics of a room sensor. To be able to successfully complete this tutorial, you will need the basic setup for all devices, my ESP Foundation tutorial. Today we will start with the Bluetooth temperature and humidity sensors. Now the temperature and humidity sensor is the same device. It's going to be, in my case, a DHT22. I will talk about it a little bit more a little later on in this video. After that, we'll be adding some more sensors. Illumination, ECO2, TVOC, movement detection using a PIR sensor, presence detection with a millimeter wave sensor. We might add a screen, and if I have time, touch to the screen to be able to switch on lights or open doors, something like that. I will add all of these sensors over the coming videos. I don't know when these videos are going to come out, but I am going to try to make them as regular as I can. At the end of the project, I intend to have a full room sensor that works for all of us. You can subtract from it, you can add from it, but also what I will be doing is at the very end of this is add some specific. For example, in the kitchen, you may need a gas sensor for either natural gas or LPG. And we will work on building such a sensor for the kitchen. In the garage, you might want to have a distance sensor for when you park. We will then build one of those as well. So all of this is in the planning, and there will be others, I'm sure. If you have any ideas of what we could do for a room sensor, please don't hesitate. Put it in the comments below. I read all of my comments. I reply to all of my comments. A little self-serving reminder, don't forget to like, subscribe, and hit that notification bell. Also, all of my tutorials have time codes or chapters attached to them below. Before we start building, I'd like to give you the bill of material. We're going to start with the ESP development board. Mine is an ESP32S board, but any ESP 8266 or 32 will work. You might have to readjust some of the pins. A suitable USB cable. In my case, my USB cable is a micro USB. A 10 microfarad capacitor. Now, this is not required, but it makes it easier to dump the firmware using the USB port. And I'll explain to you later why. A breadboard, some breadboard jumper wires, U-shaped breadboard jumper wires. This is an option. This is optional, but it will make your life much easier, I promise. And obviously, either a DHT11 or 22 temperature and humidity sensor module. You can use a DHT11. I will be using a DHT22, and I will explain to you why later. In the coming videos, we will also add a BH1750 light sensor, and we will talk about the advantages of using I2C or I2C. Then we'll add a GP30 air quality sensor module. This sensor module is the only one that I could find in South Africa at the time of recording. There are others. They all work pretty much the same. So if I do this one, you'll know how to do the rest. A PIR sensor for movement detection. Then we'll talk a bit about Universal Asynchronous Receiver Transmitter, or UART, and the protocol behind it. And then we'll add an LD2410C presence radar sensor. That is a tricky one, so it might be longer than the rest. And at the end, I will replace the DHT11 or 22 with a BME 280 and an SHT40 just to show you what we can do with I2C. I2C allows us quite a lot of flexibility and chaining of sensors. Software-wise, the requirements are very simple. We need Home Assistant and we need ESPHome. That is it, nothing else. So instead of carrying on and talking about things, how about we start building? Before we carry on, I'd like to talk quickly about something that's relatively important. For each device that we are going to use, be it an ESP32, 32S, 32S2, C3, or an ESP8266, there are pin assignments to them, and these are usually done per manufacturer. For example, an ESP32 CAM will not have exactly the same pin assignments as a ESP32 D1 Mini. And the D1 Mini would not have the same pin locations as another ESP32. To find which pins you have for the given ESP or any other microcontroller, you will have to find the manufacturer's pin out diagram. And this is what we have in front of us, the pin out diagram. This is the one that I use, which is the ESP32S from AI Thinker. This is the board that we are going to be using right through and that we have already been using in previous tutorials. I will leave a link below with the address of where you can get this diagram and a little bit more about this specific NodeMCU. Today, we will be using GPIO26, which the arrow is pointing out right now. Okay, I think this was something that was very important. You do need to get the documentation for your MCU. And not all MCUs have the same pin diagrams. I got caught out thinking that the NodeMCU and another MCU had the same pin assignment at the same place. This is a good way to blow up one of your microcontrollers. Before we continue, I'd like to speak about the differences in between the DHT11 and the DHT22. Although you can use either of them, there are major differences to them. Not in the wiring, but in their sensitivity and in their range. So to give you a fair idea of what the differences are, the temperature range of the DHT11 is from 0 to 50 degrees Celsius, whereas the DHT22 is from minus 40 to 80 degrees Celsius. The humidity range for the DHT11 is in between 20 and 90%, whereas the DHT22 ranges from 0 to 100%. Additionally, there are some resolution changes between the two. For the humidity and temperature, the DHT11 has a 1% or 1 degree step, whereas the DHT22 has a 0.1% step on both. Lastly, and possibly not as important, but worth remembering, is the sampling period. The DHT11 can sample at 1 time a second, whereas the DHT22, 2 seconds to refresh. So you cannot request the data from the DHT22 faster than that. Now, The ESPHome libraries takes care of all of this. So you don't have to worry too much about it. I just wanted to make sure that you understood the differences between the two. Now, in this project, you can use either, and the pinouts are exactly the same. So let's move on to that. The first pinout I'm going to talk about is the VCC or power pinout. For the DHT22, the power can be in between 3.5 volts and 5.5 volts. The second one is going to be the data. Now, we are getting serial data out of this. It is a digital output, so we do not need an analog pin. And the reason why I chose GPIO 26. The last pin is ground. Obviously, it's going to go back to the ground. Now, you're going to see all of this in more details shortly when I show you how to wire it. As you can see, I have prepared the breadboard with all we need. You can see the DHT22, this white little block over there. So let me just explain to you what I've done. I have hooked up the VCC to the positive rail, the ground to the negative rail. These rails run this way, whereas these rails run this way. Okay, so the next one that I need to talk to you about is the 10 microfarad capacitor, which is only there so that we can actually use the serial in without having to push any of the button, particularly this button over here. The data, the serial data from the DHT22, as you can see, comes into GPIO 26. Let's go and do some code and see if all of this works. Here we are ready to do some YAML code in ESPHome, but before we do, some things that I wanted to point out. The first thing is that our version of Home Assistant is now 2024.3.0. And the second one is that our ESPHome version is currently 2024.2.2. Both of them have changed during the time that I was preparing for this recording. And I thought I would tell you where I am now so that we are on the same footing. Okay, so we can go straight to ESPHome, and I would like to show you a little something. I'm going to go into our last tutorial regarding ESPHome, and I am going to scroll all the way down, and you will see here we have 202 lines. Why have I done that? Well, I want to show you this one. Now, this is a brand new device. I primed it like I primed the original one that I did in my first tutorial, where I show you how I prepare my ESPHome devices. And you will see that this device also has 202 lines. And that's because both of them are using exactly the same code, at the exception of what is in the substitution variables. I've just changed the name and put a new IP address. We can move on and start doing some code. The first thing that I'm going to do is I'm going to go just on the Wi-Fi. And this is because I like to have some order. Wi-Fi is a communication system, and so is Bluetooth. So I am going to put Bluetooth under Wi-Fi. I have this prepared, and it is in another screen. So I'm going to copy the code here, and I am going to paste it right for you. I know that caching will give us some problems, and I also know that my code is not quite correct. So I'm going to go and fetch this device internal name. And I am going to change the device name to device internal name. Why does the cache service doesn't work? Well, the cache service is a ESP IDF function. Just so that I explain to you, there are two ways of compiling. There is the Arduino framework or the ESP IDF framework. Oddly enough, as I think I explained in the previous one, the Arduino framework for ESP32 actually leverages entirely from the ESP IDF framework. Now let's go through Bluetooth. I am going to just scroll it a bit up so that we can all see it. Here we are. The Bluetooth proxy, as you now very well know, extends the Home Assistant machine's Bluetooth abilities beyond its range. So wherever your proxy, it plays the game of switching from the whatever the Bluetooth signal is on the one side and outside of the range of the Home Assistant machine, and it forwards that to the Home Assistant machine, or the other way around. So it's basically like having a long cable with a Bluetooth dongle at the end to extend the range of Bluetooth. That is all well and fine, and it's not a problem. The next one is the Bluetooth Low Energy Tracker Hub. The Bluetooth Low Energy Tracker Hub is very intensive on the processor. So we need to use this sparingly. In fact, I would even discourage you from using it unless you know exactly that you're going to need it in that position. And that's because you lose the ability to do other things, web server being one of them. The tracker and the web server at the same time do not work. I have tried on many occasions and I end up with a microprocessor that just reboots and reboots and reboots or boots randomly for no reason whatsoever. If you are going to have a Bluetooth device or many Bluetooth devices in a room, sure, use it. If you're not going to have any Bluetooth device in that room, comment it out. Rather have the web server. It's far more useful. And I think I explained why it is useful. It allows us to debug. But beyond all of that, it also allows further things, which I will talk about in one of my quickies. It is related to the way that we can connect an ESP32 ESPHome device to a new network. So the Bluetooth proxy is active equals true means exactly what it says. Here it is. I'm a proxy. I'm active. Use me. The Bluetooth low energy tracker hub, it's okay, fine. I'm going to scan for stuff that I can track that announces itself. And I'm going to do that at every 1100 milliseconds or 1.1 second. Why would that be useful? I have a Mopeka Pro Bluetooth device, which allows me to monitor my gas bottle fill. So I know when I get too low, about 10%, it actually sends out an alert to me through Home Assistant. It is a Bluetooth device and it is outside of the range of my Home Assistant server. I use it there. I also use the same ESP32 to monitor any gas leak around the bottle. There is a good case for that. I am gonna stop about Bluetooth at this point in time. We will treat Bluetooth devices in more details, especially I think the Mopeka Pro, and I'm hoping I've got the name right, because it is an interesting device. I am gonna compile and install this. So let's go to install. And because it's been primed with my code already, I know that it has wireless ability.
A few moments later.
We are waiting for the ESP32 to respond. And there we are. It is responding. I would like to show you that the BLE is indeed installed, and you can see it right there. And there we are. We are now reading data from our ESP. Now let's talk about adding the DHT22. I think that I've covered the DHT22 in enough details previously, so all I'm going to do is add the code and explain to you what the code does. I am going to go down and go all the way down to my sensors area. There it is, sensors area. I am going to do some space for us and go back a little bit and just paste my code. So here is the code. I like neat code, so I will do this. Okay, so the platform is DHT. The GPIO that we opted for is a GPIO 26. And I chose that one for a good reason, and I will be honest with you, I cannot remember why. Then after that, it's simply temperature. And as you see, name temperature, ID, and humidity, name humidity, and an ID. Now, I have a tendency to put IDs to everything. And that's because in Home Assistant, if you've got an ID, you can actually do some manipulation and changes inside of Home Assistant that you can't do if you do not have a unique ID. Okay, the model is a DHT22. Yes, if you use a DHT11, it would be DHT11. And lastly, update interval is the update interval that I set at the top of the file. Now, just to show you what that update interval is set at right now, it is 30 seconds. Okay, let's go back over there. And this is everything we need to do just to get a DHT22 to work. I will be honest with you, I'm going to cross fingers and touch wood and hope that it works. As I said, the ESP32 is primed and we can do an OTA and wirelessly, and here we go. It's going to be much faster than the last one. Now, the last one took a little bit of time. It had to download certain things and it had to do a few other things like compile everything. This time, we're only compiling 2, so it should be pretty fast. There we are, and it is uploading it.
A few moments later.
Now we are waiting for the device to respond back after a reboot. And here we are. Okay, I am going to scroll down a little bit so that you can see where the DHT is being initialized. And we're going to go down and we are starting to get data. So I must have prayed to the right computer gods, and we are getting actually 28.1 degrees and 40.3% humidity, which is highly likely. We have a storm outside and it is raining, and the temperatures right now are very high. Okay, and yes, it is 10 p.m. That covers everything I wanted to show you inside of ESPHome. So I am just going to go stop. I am going to close, and our device is indeed online, and I get a notification. A new device has been discovered. I am going to dismiss it because I do these things. I'm going to go to settings, device and services, and you are going to see, oh, I was talking about the Mopeka check, and it is available to me right here, right now, and through that Bluetooth proxy. It is a Bluetooth one. It is sitting on the other side of the wall, so obviously it will pick it up. The one that it did not pick up is the ESPHome device that I want us to use. I see why. I had primed the ESPHome room sensor device previously. So we're going to go into it And as you can see, the humidity is appearing, the temperature is appearing, and all of the other things that we have set up is appearing. So how do we go about putting that into the dashboard? I'm not going to go into funny things today. I will have a separate video regarding how to build a dashboard with YAML. I know there are new functionalities, drag and drop, that was introduced in this version of Home Assistant. I'm still a bit old style. I like the control that I have when I do things by code. But just to demonstrate how well all of this works, we are going to just go add to dashboard. And this is what it will look like. And we are going to just add it to the dashboard. If we come back to overview, here we are. This is the data that we have. Right now, we do not have any fancy, I don't think we've got anything fancy that we can do with it.
A little longer than a few minutes later.
Here, we've got one. Right now that's a signal sensor, but what we want is, let's use a let's use the temperature. The room temperature sensor, and the units and everything else is good. We are going to put if I could spell temperature, right, sure. And I guess we should say room in front. The unit is degrees centigrade. We're not going to change there. The minimum, I'm not going to change. The maximum, let's put the minimum at 0 because it's a room temperature, and the maximum we are going to put at 40. What do you think? So we can display it as a needle, as a needle gauge. I don't like that. Severity, no, that's fine. Okay, so we are going to save that, and we are now with a room temperature of 28.2. I wonder if, no, it's not there yet. Okay, and we can add another card, same one. If I can find it again, here it is, and we are going to take this, and we are going to say humidity, and humidity obviously humidity, and as I was about to say, humidity starts at 0 and the maximum is 100. And we're going to save that, and now we have both room temperature and room humidity available to us on the dashboard. I am going to wrap off for today. And the next one, I will be adding a light sensor, and it is going to be a quickie. In fact, the next few are probably going to be all quickies until I do presence and movement, which I will possibly do in one single tutorial. Anyway, I think we've covered this very well. If you liked the video, obviously, please do not hesitate to click the like button. If you want more of these, hit that subscribe button. And if you want to be notified, hit that bell icon. This is Pascal signing off. Until the next tutorial, have a great one.